We see 3D printing taking a larger and larger role in the company. It saves us a lot, and that makes the investment worthwhile. My name is Douglas Winker. I am the product line manager for acoustics and principal acoustics engineer at ETS Lindgren. We're based in Cedar Park, Texas, which is in the Austin area, but we have offices and factories globally, and we manufacture test and measurement solutions for RF, wireless, EMC, acoustics, and medical shielding. I got into 3D printings when I was locked up at home over COVID. I bought an Ultimaker off of eBay, and I don't know how to get this thing to work, which it was a lot harder then, and just got on YouTube and started watching stuff, and that's kind of what I do. We got into 3D printing because we do a lot of custom low volume parts. Everything's unique, and we customize a lot of things to our different customers. And we started looking into additive, and we started, like everyone would, with a cheap consumer grade 3D printer, and we took that as far as we could, but we saw the benefits of additive as to what they did for us for customization, quick turnaround, making parts that are a lot cheaper than sending them out. Plus, we were having a lot of 3D printing outsourced, and we looked at the amount of money we were spending on 3D printing, outsourcing that, and decided to bring it in-house and buy a more professional machine. We wanted to get into high temp materials because we had topped out at ABS, ASA, and some nylons, and then when we printed larger stuff, it would warp. We just had it where it would warp and the edges would peel up, and and then after that, that takes quite a while to run. So you start a print, and you come in the next day, and you got to start it over because parts come up, and we just got tired of that. And it cost us a lot of money to throw those away in time. We found Vision Miner through YouTube. So as we were trying to learn about 3D printing and bringing additive into the company, a few of us watch YouTube religiously, and that's how we learn. And we found all your videos and found them to be very educational. And as we were learning about them, we looked at the printer. And then last year, I went to Rapid, looked at the 22 IDEX firsthand, saw the build quality, saw what the machine was all about, because the price tag was significantly higher than what we've been spending on machines. But you can obviously see the difference. You could see why it was more. And looked over the machine, and we decided to come back and try two of them out, and they've been fantastic. It fit our needs. It was something we could bring in house, and it was a machine that we had control over the process, and we could use any of the filaments we wanted. So it was a natural fit. One key aspect on our RF chambers is that all of the components inside the chamber need to be non-conductive. So they're made of plastics, they're made of polymers, they're made of different materials, but no metals. So we have to build standard tripods or jigs or things that hold antennas. All of that has to be made out of a plastic, and a lot of it's custom. So that's one of the reasons that 3D printing and polymers are so important to us. One of the things that's been a real benefit for us with the 22 IDEX and bringing FDM in-house is our design team and our manufacturing team and our engineers were able to look at the printers while we're using them and come up with new ideas for how we're able to use the printer. We've also brought a lot of parts in-house that we were manufacturing externally, which is more economical. But as we bring them in-house and we deal with the challenges of how do we print this, how do we get that part to come out, we come up with new ways to do things. For example, we had a part that we were getting machined out of aluminum for a positioner that was very, very expensive. One of our design engineers had seen the 3D printers, looked at what our cost was for that machining for that part, and found out that he could make it out of Ultem and it would last long enough because of the material properties of Ultem, and it turned out to be cheaper to print it in Ultem than to get it machined in the way that we need. So this is a section of a gear train that we print in Ultem that replaced a machined part and is actually quite a cost savings for us. And we print a lot of these, and it bolts in, and it's a gear train that teeth right along, and it works out great for us. So one of the things that we use the 22 IDEX for is printing welding jigs. So we have some hinges that we manufacture. We were printing a jig out of PLA because we just had a cheap printer that held the barrel of the hinge to the plate of the hinge for when they would weld it, and they would come in and spot weld it, and the PLA part would liquefy because it was really hot. So we printed these little parts out of Ultem, and they work great. And this is a brand new one, and this is one that's been used 4 or 5 times. And it's got a little bit of char on it, and they last, and we switch them out every week or so instead of every hinge. And they work great. Now, all we do is tack weld them, and then we remove them when we do the bead weld. But they're perfect for that, and all they do is get a little bit of char on them. And other than that, they're perfect and can be reused. So this is a cap for one of our positioning devices, and we printed this entire part. This is made out of ABS. So it's just an ABS part, but because you print it can warp up on the bed, but in the heated chamber it stays flat and comes out good every time. Another really important feature for the 22 IDEX for us was the ability to control all the communications in-house, the ability to remove Wi-Fi if we needed to be ITAR compliant, because we have a lot of customers and a lot of industries that we serve where that's important. So some of the consumer grade printers like to phone home or use the cloud, and we're unable to print parts using those printers because of that, and we don't have control over the firmware, what's getting out, and because of that we couldn't trust those printers. So we have the 22 IDEX, which we know we have complete control over and can keep it inside in-house and make sure nothing's getting out of our ecosystem. With the nanopolymer adhesive, by the way, nanopolymer adhesive was our first Vision Miner product. We bought that 2 years ago, I think, when we were looking for something to try to get our nylon parts to stick. Our engineers thought they had to coat the nanopolymer adhesive every time they used the print bed. And then we always clean our print bed with IPA. And we didn't know about the nanopolymer adhesive and how it worked at that time. And so it got to be where parts would not come off of the print bed. We reached out and we learned that IPA doesn't clean nanopolymer adhesive, it just helps redistribute it. And then we added it every time we used the print bed, which we didn't need to do either. So we washed them off and cleaned them off as we instructed. Now they work great, and we're using it as directed. But yeah, it was, they're like, I don't know about these carbon fiber print beds, so the parts never come off. One thing that's been a real benefit with the 22 IDEX is the fact that it's built on Duet hardware. Because we've had printers go down in the past, the consumer grade printers have gone down in the past, and it took us a month to get them back online. Where with the Duet, we can order parts from you, and if you don't have it in stock, we can find it from any number of vendors, and it's well documented how to plug it in and get us back up and running quickly. There's so few parts in here that would break that are proprietary. If I needed a new hot end, or I needed a new board or something, and you didn't have it in stock, I could source it and I could get back up and running quickly without the downtime of my printer's been sitting on the shelf with, a bad LiDAR scanner for a month and a half, and they won't send me one. We like the idea of the dual extruders because we like the idea of using a different material as a support structure, so the supports break away easier, so you get a better finish on them. So having the IDEX, we can print with one material, then come in with a different support structure, or we can do two colors, so we can put our label on stuff, or we can put lettering on a part, and we do that often on parts as well. So having those two extruder heads are great. And then we also take advantage of it when we're printing those small parts. If we're going to print a plate of them, why not use both print heads and get it done in half the time? One of the things that's great about it is because we do a lot of custom work, we have to do a lot of iterations on our designs, and things are changed, and it's nice to be able to print the part, even if it's going to be a machined part, and hold it in your hand and say, okay, this doesn't work, or this doesn't quite made up, and we can make some adjustments to it. And then we can take that out and have it made out of aluminum or the other parts if we need to. And then we save the 3MF file. So in the future, if anyone needs that part again, they just get the 3MF file, put the right filament in, and out it comes again. We see 3D printing taking a larger and larger role in the company. And our designers are starting to think about 3D printing and how to design for additive. And they're starting to come into the mindset of, why have that part machined when I can 3D print it? Because 3D printing is much more cost effective. Instead of having to run through a machining process, if we can print it, you put it on the machine, you hit print, and you walk away, instead of having a multi-stage process of getting the aluminum, cutting the aluminum, machining the aluminum, and all that adds cost. Right now we've got a couple of these printers and they're going 24/7, and we're starting to run into capacity issues. So we're looking at how to add additional printers, and we're also looking at other technologies because we have solutions that aren't applicable to FDM. We've got some parts that have to be made with a powder process, and right now we get them made with multi-jet fusion. We've got other parts that we've identified that would work really well in SLA, and that would save us a lot on parts because everything's custom. And so now when we order parts, we have to order a minimum run of the parts, and that could be a year's supply, where our 2 years supply minimum, so we don't order the parts as often, where we could just print them as we need them, because as I say, everything in our business is different. Every solution is a little bit different or a little bit tweaked, and because of additive, we can tweak it to whatever our customers need. One of the things we were doing online today is we were looking, because we were talking to the designers about taking a course in designing for additive, and we were seeing if there were certificate courses or online courses in that, and we found that there's actually courses like at the University of Texas or Penn State or various other universities where they're teaching courses to their students on additive. And so we were looking at the textbook list and saying, okay, maybe we'll buy some of those textbooks and teach ourselves. At this point, Ken, everything's been fantastic. We have no complaints, and our responses have been really, really fast and very accurate. And we don't have any delays in response. It's been exactly what we want. But as far as learning curve, the learning curve wasn't that hard because the other slicers we had used were based on Prusa slicer, and some of us, I personally and some others, have had experience with Prusa slicer, so it was just bringing everyone up to speed, changing our processes. There's some differences in the terminology. We've primarily been using Orca slicer, so there's been some differences in terminology that we just had to get everybody set with. And other than that, it was fairly easy. It was an easy transition. It's been great. The communication's been great. There's no question we can ask that's too stupid, because we're trying to learn this high temp world. We get feedback, we get it really quickly, and everyone's been fantastic, and they help us along with that. And when we're in the middle of a project that's costing us money, and we're able to get an answer, and continue and finish that project the same day, it saves us a lot, and that makes the investment worthwhile.